sheet. And let's just start with the first one on the page. I have, for number 7, right here, I've got an angle that is labeled as being 68 degrees. And I have an angle that is labeled as 5x plus 3 degrees. So, does anybody have an idea about what we might need to do to solve for x here? How are we going to start this?
5x plus 3.
Okay, we're going to use that 5x plus 3 for sure. How are we going to use it though?
68 plus 5x plus 3.
Okay, so add these two angles together. Okay, so what's that going to do?
Equal to 8.
Ah, there's what I needed. Okay, so I know that right here, because this is a straight line, this whole angle altogether is how many degrees? It's 180 degrees. So that would mean that I should be able to add this angle, which is 68 degrees, plus this angle, which is 5x plus 3. So let's do that, plus 5x plus 3. And it should equal 180, since these two angles are what make up the 180 degree angle. Okay, so here's our first step. We set up the equation. Now, before we go any further, I want you guys to be really honest with me. I will not be frustrated. I'm not upset. I want you to understand who is lost at this point. Are you feeling okay? I know you missed the last couple days.
I'm completely lost, so I'm just trying to listen.
That's okay. No, I'm glad you're telling me. Let's go a step back. Let me get a separate sheet of paper and explain this in a little more detail. I want this paper. Okay. So, let me start from the very beginning, and I want you to, again, be super honest with me. I won't be upset. I know you've been sick, so I'm happy you're feeling better, hopefully. Are you confused at all about how this straight line is 180 degrees?
No, I get that.
Okay, good.
The other angles added on, it confused me. Like, is it supposed to be more than 180?
So here, let's explain it in this way. First of all, it's going to be equal to 180. Like if I had a straight line, a straight angle, and I'm just going to kind of redraw this picture. I also have a random line sticking out down here. Now that line's just extra information. We really don't need it. I've got 68 degrees, and then this one is 5x plus 3 degrees. Instead of worrying about the number values, let's just call these angle A and angle B. So here's A, and here's B. So, since A and B combined together make up this 180 degree angle, are you with me so far there? I can say A plus B, when I add them up together, it's going to equal 180 degrees, right? So, I know A plus B is 180. All I'm going to do now is replace A with 68, because I know what A is. A is 68, because I told you that. So instead of A, we'll put 68. Now, instead of B, what should we write instead?
5x plus 3.
Yeah, 5x plus 3. So let's do that. 5x plus 3. And now we're just going to write the rest, which is equal to 180. Okay. So that's how we got this equation here, which is exactly where we got right here. So we're to that step. Are you following so far? Is that making sense?
Yay.
Okay. So let's continue. Whenever I've got an equation like this, there's a lot of things going on, first of all. I've got a 68, I've got a 5x, I've got a 3, and that's all on just one side of this equation here. So my equal sign is kind of dividing the two sides of my equation. How could I combine some of these terms here, or some of these numbers, before I start trying to solve? Is there anything I could combine?
68 and 3.
Yeah, 68 and 3. Those are just normal numbers. They don't have any variable on them, so we can go ahead and add them together. What is 68 plus 3?
71.
Yeah, 71. So I've got 71. Get rid of those. And I still have plus 5x equals 180. And now we're to this point. Is anybody confused about how we got here? Feel good? Everybody feel good? Good.
I just
Okay.
did my equation back. But I did it.
That would still work. That would still
Yeah,
work.
yeah, but no, yeah.
Well, good deal. Okay, so now we're here. What do I do next?
Subtract.
Yes. What am I subtracting? 71. Minus 71. Because we're trying to get x by itself. And this 71 is preventing me from having x all by itself. So let's subtract 71. So those will cancel. I'll be left with 5x equals 180 minus 71 is, I got 109. Did you guys get the same thing?
Yeah.
Awesome. Okay. And what's my last step? Divide. So divide by 5. 5's will cancel. So I've got x by itself equals, what's my answer?
21.
20, you say 21.8?
8, yeah.
21.8.
I just said I was like,
Woo! No, 21.8. So our answer for number 7, first problem on our worksheet, is a continuation of yesterday's worksheet. Why it's 7. We would say x equals 21.8. Good. Any questions about that one? We feel okay about it?
Can we do another one?
Yeah, we're gonna do all 5
Okay.
things. Absolutely. Okay, let's look at number 8 then now. So number 8 is dealing with a different set of angles. What are some of the things we can identify in number 8? What are some things we notice right away?
Can't think of the word. There's 2 parallel lines.
Yes, we have some parallel lines. What tells you that these are parallel?
The arrows.
Yeah, there's some arrows right here in the middle of our lines. That means we know that these are parallel. So if we have parallel lines, what is that going to tell us about the angles that this transversal creates? Remember that word? Transversal?
They're corresponding.
Yes, that means that these angles here, the 87-degree angle and the angle that's 2x plus 5, these are corresponding angles. So how do they relate to each other?
They're the same.
They're the same, exactly. I also kind of gave you a hint. I put the little arcs, the same arc on it. So these are the same. They have the same measure. So again, if this was like angle A and this was angle B, what could we say about A and B?
Both 87.
Yeah, A and B are both 87. I know A is 87, B is 87. I could also say that A is equal to B. I could also,
What is the number like that it has to equal?
Hmm?
So like, you know how the last one equals 180? What does that look? What's number 8 supposed to be?
so number 8, this is what we're gonna do. I know that angle A here is the same as angle B, so I'm just gonna set them equal to each other. 87 for A equals B, or 2x plus 5. Like that. And then we solve for x. So whenever our angles are equal to each other, we just set them equal to each other and we solve. Just like this. Now, before we start solving this, does anybody want to go over again how we got to this point? Or are we feeling okay? Feeling okay?
Wait.
Yes, tell me. What's up?
Okay, so I'm confused. 'Cause
Okay.
At the end of mine, that's not a 180. That's not a 180 angle, is it?
Say it one more time.
That's not a 180 angle, is it?
So this angle, the 87 degrees, and
Or it tells you the angle.
this angle gives us 180 degrees. Also, this angle and this angle gives us 180 degrees.
Okay, well, I have that. I mean, I did that, but at the end, you see how you have 87 equals to x plus 5?
Mhm.
Doesn't the 180 doesn't matter, does it? At
No.
all?
In this case, knowing that this is a straight angle will not help us. Because
Because the only reason why I said that is because the way I have my equation is I have 2x plus 5 plus 87 equals 180.
But do they equal 180 when you add them together?
Technically, no.
No, they don't. Because 87 degrees is an acute angle. And then this angle right here is also 87 degrees. I know it is because it's the same as the first one. So I can reason 87 plus 87, it's not going to reach 180. It's less than 180.
Yeah.
87 plus 87 is actually pretty close. It's 174. So 180 isn't going to help us in this case.
Okay.
Whenever angles are equal to each other, like these corresponding angles here, we just want to set them equal to each other. So that's why I put 87 equals 2x plus 5. Or you could do 2x plus 5 equals 87. Does that clear it up a little bit?
Yeah.
Okay, cool. All right, we ready to try and solve this one now? Okay, what's my first step?
Subtract about.
Yeah, let's subtract 5 from both sides. And what's 87 minus 5? It's 82. Yeah. Equal, we still got 2x. And what do I do next?
Divide by 2.
Good, divide by 2.
And it is 41.
Yes, ma'am. 82 divided by 2 is 41. That's our answer for x. Perfect. Number 9 is really similar.
I feel it was off, see. Sorry.
Oh, you're good.
I was off because my answer was 44. But that's because I had that one thing right there.
Right, right. It was
Okay.
really close because 87 is like super close to 90. So, you know, my angles aren't drawn perfectly accurately, but you know, you get the idea. All right, any questions about number 8? We ready for 9?
Yeah.
Okay, let's do number 9. So, number 9, what's going on here?
The same thing.
It's the same thing. We've got another set of corresponding angles. So, what's the relationship between these angles? What's happening here? Yeah, they're equal to each other. Perfect. These two angles are equal to each other because they're in the same location of their little angle family that's happening here. This cross section of these parallel lines, you see that? They're in the same position. So these are corresponding angles. They're equal. So how would I set this equation up?
103 equals 4x plus 3.
Perfect. 103 equals 4x plus 3. And what do I do first?
Subtract.
Yes, let's subtract 3 from both sides. And that would give me
Right now.
100 equals 4x. And what do I do next?
Divide.
Divide. 5 by 4. Perfect. What's 100 divided by 4? 25. And that's our x. Very, very nice. Are we saying what out of confusion?
No,
What's going on back there?
nothing. I was just sitting here thinking about something.
Okay. I
That
got
just
you.
went on. It's just crazy.
You're good, girl.
Evansville's crazy.
Yes, it is. Evansville is crazy. I'll tell you that for sure. All right. So 25 is our x here. Any questions about number 9? Everybody feel okay about that one?
Now I think I get it because
Yay.
I don't see like the big old wide opening like the 180.
Yeah.
So now I think I get it.
Good.
Problem I had, I was like, why does it have to equal 180?
Yeah, I know.
Right.
Yeah.
Okay, good. Well, I'm glad it's making sense now, guys. That's awesome. Okay, let's look at number 10. What kind of angles are these? They are congruent. You're absolutely right. These angles are the same as each other. You guys remember, we talked about it for just a second. Do you remember what it's called when two angles are right across from each other? It's okay if you don't. I'm not going to quiz you over that.
Adjacent?
Ooh, so adjacent is like these two angles where they share a line and a vertex, or a ray and a vertex. So if they're smushed up against each other, they'd be adjacent. What about vertical? Yes, somebody said it. Vertical angle. Vertical angles are congruent. So how would I set up this equation?
2x equals 84.
2x equals 84. And this one's a pretty quick answer. All we do is divide by 2.
Divide by 2.
That's it. And I'm going to get x equals, I think it's 42. Is that right, guys?
Yeah.
Perfect. X is 42. All right, one more. Number 11. This one's a little tricky. A little bit tricky. Anybody have any ideas about number 11? What's going on here?
You do the same as when it's 180, but you equal it to 360.
Yeah, okay, so we have a bunch of angles that are sharing a point. They're angles around a point. So what's happening here is we're making a full rotation, a full 360 degrees. So I know if I add all of these angles together, all 3 of them, I'm going to get 360 degrees. So why don't we do that? Why don't we just add them together? What should I write for my equation?
I did X. Wait,
Why
where
is-
we at? Okay, I did X minus 26
Mm-hmm.
plus 94 plus 3X
Uh-huh.
equals 360.
That's perfect. Now, pause. What were you asking, Cheyenne?
Sorry, but why is there like a subtraction instead of adding in this one?
Good question.
I did subtract that. I'm sorry. I might have got that wrong, but
No, you're good. You're good. So, I don't know if I have a really good answer for that. It's just sometimes in math there's subtraction, I guess. What do you mean by why is there subtraction?
Like, do you actually subtract it, or like, I don't know. It's throwing me off.
Yes, it is totally different. So I guess we have had addition and all the rest. So the only thing that's, I guess, different about having a subtraction problem is whenever so like first let's write out what we got going on. So Lexus, can you repeat the order you wrote yours in?
Yeah, I did x minus 26.
Okay, so here's our first one. I'm gonna write that. X minus 26. And what'd you do next?
Plus 94.
Okay, plus 94.
Then plus 3x.
Yeah. Plus 3x
Equals 360.
equals 360. Okay, so the only thing that's going to change with subtraction is whenever we're combining our like terms, like we've got, let's look at them first. Got an x and a 3x. Those will go together. And then I've got 94 and minus 26. The only thing it's going to change is that instead of doing 94 plus 26, I'll do 94 minus 26.
Oh, I got that one wrong.
Uh-oh.
I think
That's okay.
I did.
So here, let's see what's happening. First, let's combine our x's. What is 3x plus x?
4x.
4x. Good. So let's write that. 4x. And then 94 minus 26?
68.
68. Good. So let's write that. And is it a positive 68 or a negative 68? Positive. It's a positive. We only took away 26. We started with a bigger number, 94. So plus 68. And it's still equal to 360. Okay. So we're to this point.
This is the easy part.
The easy part, yeah, solving the equation once you got it all together. I think what gets the most confusing for most people that I've noticed is combining like terms. I think that confuses people.
Yeah, I used to have a really big problem with that when I was in high school.
Right.
Like whenever you had to simplify,
Yes.
for example, I was so bad at that.
You're not alone. You're not alone. That is, I mean, we've spent just about a whole week with my algebra class just getting this down. Because if you can't do that, you cannot do other equations. We got to get that down. So I'll get you guys some practice on that if we want it. And how am I going to solve this now?
68.
Okay, what am I going to do with 68?
You can subtract.
Yeah, let's subtract 68 from both sides. So I've got 4x equals what? 2 what?
92.
292. Good. And what's my last step?
Divided.
Good. Divide by 4.
73.
X equals, everybody get 73?
Mm-hmm.
73. Here we go. All right. That's our answer.
Can I get some practice in it?
Yeah,
Please.
absolutely. Absolutely. Is it just kind of the combining like terms and equations that's getting us a little mixed up?
Yeah.
Absolutely. So I know Lexus, you asked for some earlier. I'm gonna get both of y'all some. Honestly, I'm gonna make copies, and if you want them, take them. Like take them. I'll make enough for everybody. Okay. Are we good on this worksheet? Everybody got things written down?
Will they have like graphs on it?
Graphs.
Like these. Like, do you have some of these on it?
Like this?
Yeah.
Yeah.
You want it to?
Yeah.
You got
Just
it.
to make sure.
Yeah.
I can do that. I can do that. Let me make a list of what you want.
Like,
Do you already have an exit ticket for today?
We don't have an exit ticket today. I'm giving you guys a break today.
We should just do one of those as our exit ticket.
Yeah, absolutely. So here, let's see. We want corresponding angle problems. Is it mostly the ones messing you up where you have to set them equal to each other?
Yeah.
Okay. So we want corresponding angles. We want vertical angles.
And then another one that I got mixed up was 11.
Like the
did subtract.
360.
Yeah.
Ah, okay, so I want to make sure I put some subtraction in there. All right, we'll get some good practice in there,
And
guys.
8. I think I need 8, like 8 too. I think that.
Yes. So for number 8, we've got corresponding angles.
Okay.
So I got that on the list. We'll make some.
Okay.
I'll do that today while we're working. And I will have them hopefully no later than tomorrow. That's what I'll do. Okay. All right, guys. We're going to learn something today. I'm just going to introduce it to you. Just going to introduce it, and we're going to come back to this later. But I would like you to start a page of notes. And I'm also going to pass out this. Everybody's going to get one of these. Don't freak out. I know. These scare everybody. And I promise today, my goal is not for you to be masters of this. My goal is just to show it to you. Okay? We're just going to show it to you. Not yet. That's actually more of an algebra thing. So we probably aren't going to be dealing with slope too much in here. But I don't know. I have to look ahead and see what the plan is for the rest of the year or the term. Okay. So we have here a paper with a bunch of graphs. If I were to give you a point, 2, 3. On a scale of 1 to 10, 10 being I got this, I'm super confident. 0 or 1 being I'm completely lost. How confident would you feel in this very moment about taking this coordinate I just gave you and putting it on this graph?
I think I might have been.
Okay, 10. Anybody feeling like a 1?
I'll fill in the in between.
Good enough.
Give me a
Kind of in between.
A 5, yeah.
About a 5? Okay. Okay, so we're all across the board. We're going to talk about it. So when we have a graph, we have 2 different axes. How we say it. We got an x-axis, and I always make that red. And we have a y-axis. I always make that blue. The x goes left to right. The y goes up and down. Okay? So on our x-axis, we have numbers starting from 0 here in the middle, and it's like a number line. When we go to the right, we get positive numbers. When we go to the left, we get negative numbers. So I'm going to label those for you. 1, 2, 3, 4, 5, and then it goes on forever, infinity. And then here's 0 again, so we'll go backwards towards the negative numbers. -1, -2, -3, -4, -5. Yeah, that's right. And our 0 is right in the middle. Right in the middle. I usually don't label the 0 just because I feel like it gets a little crowded in there, but you can if you want. So we've got our x's labeled. Let's look at our y's. In the same way, our y-axis, the 0 is right in the middle again. But we have, instead of left to right, we've got up and down. When we go up, what kind of numbers do you think we're going to get?
Positive.
Positive. Good. So I'm going to go positive 1, 2, 3, 4, 5. And when I go down crossing 0, what kind of number?
Negative.
Negative. -1, -2, -3, -4, -5, and they go on for infinity. So we've got our graph labeled. Now let's look at this set of numbers in parentheses I gave you. So this is called a coordinate. Everybody say coordinate. Come on, give me some enthusiasm. Coordinate.
Coordinate.
Thank you. This is a
Say something
coordinate.
else.
So guys, a coordinate is it's just like in if you just took like geography or history, we talked about like coordinates on a map, it tells you where something is. Coordinates on a graph are also telling you where something is. It's like a map. So what a coordinate is it's two numbers where the first number tells you where to put your x always. The second number tells you where to put your y. So we're going to use this as a guide to tell us where to put our point on the graph. So we always start with x, okay? And we always start on 0. So we start in the middle of our graph when we count. What's my x value in this coordinate?
2.
2.
Going over
So I'm going to go over 2. Should I go to the right or the left?
to the right.
To the right. Why?
Because it's a positive.
Positive.
Because it's positive. Good. So I'm going to go over 1, 2.
Up 3.
And a 3 because I've got a positive 3 for my y. So from this 2, I'll go 1, 2, 3. And this is where my point goes. So I'll just label it 2, 3. Just like that. That's pretty good, guys. Now, I'm going to give you one more point, one more coordinate. I want to give you the same one I gave this period 1. Let me find it. This might be dangerous, though. I'm going to be back here for hours. I have right here. Oh, sure. So now let's do -3, -4. So if I wanted to plot the point -3, -4, how far over to the left or right should I start with?
You're going to go over to the left 3 times.
Good. So -3 for my x means I'm going to go over to the -3 on the x-axis. Good. So 1, 2, 3. And then how far up or down do I go?
Down 4.
Good. Down 4 because I've got -4. 1, 2, 3, 4. Right here. And then I'm going to label it -3, -4. Just like that. Now I want you to take your ruler and create a line segment. Don't go through your line. Use those, or not lines. Don't go through these points we plotted. I want them to be end points. Make a line segment. And remember, guys, I'm just going to introduce this to you today, what we're about to do with this line segment. If you leave feeling confused, it's okay. We're going to do a whole bunch of it next time I see you. So, what if I wanted to figure out where the middle of this line segment was? I wanted to know the midpoint. Yes.
You use a compass.
I totally could use a compass. Absolutely, I could use a compass. What if I didn't have a compass, though?
Your ruler?
I guess I could use a ruler. I guess I could try to count the spaces, yeah.
Something with an equation that's really complicated.
I know. We are going to use an equation. I'm sorry. We're going to use an equation, guys. I'm so sorry. But it's going to make a lot of sense whenever we understand why this equation is written the way it is. So I'm going to introduce a formula to you guys. And this is called the midpoint formula. So here is where we're putting things in our notes. I'm going to write midpoint formula. So here's the formula. The midpoint of a line segment that has been put on a graph and you know what the coordinates are, here's how we're going to do it. I'm going to start with a big set of parentheses here. And I'm going to have my coordinates inside the parentheses. Okay, so I know that my answer is just going to be another coordinate. I want to know what point is the middle. So all I'm going to do is find the average of my x values and the average of my y values. And here's what I mean by that.
This were mode, medium, and all that.
Kind of, yeah, it's super similar to that. It's all related. So x comes first in a coordinate, so I'm going to start by taking x1 plus x2. I'm just going to divide it by 2. And that's going to be my x coordinate, or my x value. And we're going to do the same thing with our y's. I'm just going to take y1 and add it to y2. And when I'm saying y1 and y2, I just mean the x from the first coordinate, the y from the first coordinate, x from the second coordinate, y from the second coordinate. So we just add them together and divide by 2. That's how we find an average. So the average is going to tell us where the middle is. So here's that. That's our formula. You want to try to use it? Well, we're going to do it anyway. So let's try it. Let's call 2, 3 our first coordinate. And we'll call the negative coordinate our second one. Oh, you're fine. All good. So let's plug these into our formula now. What are my 2 x values?
2 and -3.
Yeah, 2 and -3. So I've got 2 and -3. And I'm just going to divide that by 2. And same thing for the y's.
3 and -4.
Yeah, 3 and -4. And I'm going to divide that by 2. Okay. So I filled my numbers in. Let's solve this. What is 2 plus -3? -1. -1 divided by 2. We could just leave it as -1/2 if we want. And how about the other one, the y's? 3 plus -4. Also -1. Still being divided by 2. So guys, promise you, it's not that painful. That's our answer. Or you could write it as a decimal if you want. You could say -0.5, -0.5. I would be happy with either. See you later, Cheyenne. Either one I'll take. And now we're going to put that on the graph. So let's look at our graph. If I started at 0, what direction do I go for -1/2? Left, towards my negative numbers. So I'm not going to go to 1 or -1. I'm just going to go about to the halfway point. That's how far over I'm going in the x direction. Here, I'll zoom in even more. I'll make it clear. So I'm going about halfway in the x. And then how far over, or not over, how far up or down do I go for y?
1/2.
Again, -1/2. So I'm going to go down about halfway through that box. And look at that. We split our line in half. That's the midpoint. That's the midpoint. -1/2, -1/2. That's it. That's all we do. Okay.
Can we do one to where we don't get a half?
Yeah, Let's do whole number ones.
Yeah.
Absolutely.
Is this the last thing we're doing for today?
Yes.
Cause I have a meeting with.
You can go. You can go. Honestly, here's what's gonna happen today. My goal was just to introduce this to you. I don't expect you to know how to use the in and outs, like feel good about it. We're not having an exit ticket today.
Okay.
I just want to show it to you. We're gonna do this tomorrow.
Okay,
So-
so can we go over another one?
Y'all are free to go. That's it
Can I
today.
have can I get the papers?
Oh yes. Yes. So are you talking about the practice problems?
Yes.
Uh-huh. Let me end this recording and